Good morning, all of you. Today we are going to solve miscellaneous exercise of chapter 1. In the previous video, we solved the examples of miscellaneous examples. Okay, so our first question is decide among the following sets which sets are subset of one and another. Okay, so what is given to us in this question is four sets are given A, B, C, and D. Okay, with various elements. Set A is given to us X. It is written in which form? Set builder form. Okay, so X belongs to R means real numbers, and X satisfying this equation. That means the value of X for which this will be equal to 0 means the zeros of this equation are the elements of our set A. Okay, so first of all you will find it. So this is the equation given to us: x square minus 8x plus 12x is equal to 12 is equal to 0. We can solve this using splitting the middle term. Okay, so this can be split into this. Now we'll take x common from here, x. So inside remains x from here minus and 6 here. Similarly here we can take minus 2 common, so again we will get x minus 6. Now x minus 6 is common from both, we will take it common, and then this is remaining. So now either x minus 6 is equal to 0, that means x is equal to 6. Okay, or x minus 2 is equal to 0 means x is equal to 2. Okay, now why we are taking this equal to 0? Because if any one of these terms or both of them will be 0, then our answer will be 0. Okay, so we got x equal to 6 and 2. Therefore we can write set A again as 2 and 6. Set B is given to us 2, 4 and 6. Set C is 2, 4, 6, 8 and continuing on. That means it is an infinite set, okay, with all the even numbers as its elements. And D is given to us as only one element, that is 6. Now we can see that D has only one element, that is 6. Okay, and that element 6 is in A here. Okay, it is in B also, and as well as C. Okay, so what I will write? I will write D is a subset of A, D is a subset of B, and D is a subset of C. Okay, now we can see that set A has two elements, 2 and 6, and that are in B as well as in C. That means what? That A is a subset of B and A is a subset of C also. Similarly here we can see that set B is a subset of C because elements of B that are 2, 4 and 6 are also contained in set C. Okay, but all elements of set C are not contained in B, that's why C is not a subset of B. So last is B is a subset of C. Okay, so in this way these sets are subset of one and another. Okay, now question number 2 is in each of the following determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. Okay, I hope you can do it very easily. If you have any problem, then you may ask, or I can tell you one or two questions. So first, it is given to us x belongs to A and A belongs to B. Then x belongs to B. Okay, we can directly first take an example. Set A is 1, or take only 1. Okay, it is a set A. Okay, and set B is 1. Okay, now it has given two things to us, that x belongs to A and A belongs to B. Okay, what do it mean that x is there an element? Okay, that x is an element of set A. Okay, so here 1 belongs to A. Okay, this thing is proved. Second, A belongs to B. A is a set A, and it belongs to B means the set A is an element of set B. Okay, I have told you that whenever this sign is there, belongs to, that means this side, the something that is on left hand side of it is element of set that is given on the right hand side. Okay, that means A is a element of B. Now what is set A? Set A is this. Do it belong to B? Yes, this is one element, so this is also true. But now if you check that x that belongs to A, x does not belong to B. Why is it so? Because B has no element that is 1. Okay, 1 along with brackets, it is one element. Okay, it is element 1, it is second. Okay, so if we want to check that elements are belonging to B or not, then for 2 we can write directly 2 belongs to B. But for 1 we will write 1 along with brackets belong to B. Okay, so x does not belong to B. That means this statement is false. Okay, in this way you will solve the remaining 5. If you have problem, then you may ask. Now, question number 3. Let A, B, C be the sets such that A union B is equal to A union C and A intersection B is equal to A intersection C. Show that B is equal to C. Okay, so question number 3 given to us is A, B, C are sets that are given to us, and 2 more things are given, that A union B is equal to A union C and A intersection B is equal to A intersection C. Now what we have to prove? We have to prove that B is equal to C, means B and C are both same set. So we are going to use our distributive law, okay, that we have studied earlier. Okay, so what was that we studied in the basics of exercise 1.4? That was, first of all, what did we have? We had A union B equal to A union C. Okay, A union B equal to A union C. Okay, now if I write it in this way, A union B intersection with B is equal to A union C intersection with B. Is there any change in this? Is there any change? No, the main statement this remained the same because we have made intersection with B both the sides. Okay, now we will use our distributive law. That means it will be A intersection B, A intersection with B, then this sign union B intersection with B. Okay, similarly here A intersection B union B intersection C. Okay, so now intersection of one set with itself, it will be the same set, so it will be A union B intersection union with B. Okay, this will be equal to A intersection B union with B intersection C. We will write the reason since B intersection B is equal to B. Okay, now A intersection B union with B. Okay, first of all, let me make one diagram to make you understand it. Okay, it is set A, it is set B. It is what? A intersection B. A intersection B union with B. Along with this is a say or B. It was A. So what will be this? This will be this region. Okay, and what is it? It is our set B. Okay, that's why this all will be written as equal to B. Therefore B is equal to A intersection B union with B intersection C. It is our first. Okay, now again I will take this. Say I take A intersection C is equal to A intersection B. Sorry, union on the both sides. We will take this statement. Again we will add, means again we will use the same way we used there, that is A union C intersection with C, and A union B intersection with C. Here we have done intersection with B and A with C, and then we will use our same procedure. That will be, it will be A intersection C union with C intersection C, and this side it will be A intersection C union with B intersection C. So here it will be A intersection C union with C, like in previous part here we have done. Okay, and this will be as it is, B intersection C. Okay, now again, as like in previous step, A intersection C and union with C will give us the same set C. sorry, here will be intersection. Okay, by mistake it is intersection here and here as well. Here intersection C union with B intersection C. Now but one thing was provided to us in the question, that A intersection B is equal to A intersection C. This was given. So I can replace this A intersection C by A intersection B. Therefore C is equal to A intersection B union with B intersection C. So it is our second. Now if we compare first and second, for it was our first, it is our second, then we see that comparing first and second, if we compare first and second, we get that the right hand side of both the equations, you can see this and this are same. Okay, because the right hand side of both the equations are same, then our left hand side will also be equal, and therefore what you will get, B is equal to C, and hence result. This only you want, you have to prove B equal to C. Okay, it was somewhat conceptual question, but it was easy. Only some presence of mind was required and knowing of formulas. A very little formulas are given to you in this chapter, and you must learn them. Okay. Show that the following four conditions are equivalent. So four conditions are given to us in this question. First is A is subset of B. Second is A minus B is equal to 5. Third is A union B is equal to B, and fourth is A intersection B is equal to A. Okay, so what they are asking in the question is that if any one of these four is satisfied by two sets A and B, okay, any of them, suppose A is subset of B, then these all three will be proved itself. Okay, if it is true, these will also be true. Similarly, if it is true, these will always be true. Okay, so this we have to prove using one example. Okay, we can take any example, taking that A is subset of B. Okay, using this condition we will make two sets, and with those two sets we will prove these three things. Okay, so let A be 1 and 2, and B be 1, 2, 3 and 4. Okay, so first one, A is subset of B, it is true. Okay, now second, if we take A minus B, okay, A minus B means the elements that are in A but not in B. You can see that A has two elements, A 1 and 2, and those two elements are in B also, 1 and 2. So if we subtract A from B, then we will get 5. 5 means no element. Okay, so second is also proved. Third one is A union B is equal to B. So what we are going to do? We will do A union B. A union B will be what? first we will write all the elements of A. 1, 2. Now we will check which elements of A are in B. 1 and 2. So leaving 1 and 2 from set B, we will not use this. We will write other elements of B. What are that? That are 3 and 4. Now you can check this was equal to our set B. 1, 2, 3, 4. So third is also true. Second was also true. Similarly, we will prove fourth. We will do their intersection. Then if we do their intersection, we will take those elements that are in both A and B, that is A intersection B will be 1 and 2, and we see that it is equal to our set A, so it is also true. Okay, similarly, if we will take two sets A and B, taking this, then also the leaving 3, the 3 that are left will be proved itself. Okay, similarly for others. So in this way you have to solve this question. Now question number 5. So that if A is subset of B, then C minus B is subset of C minus A. Okay, so we have to take 3 sets A, B and C. Fifth question is we will take 3 sets. Say A is equal to 1 and 2, B is equal to 1, 2, 3, okay, and C is equal to 1, 2, 3, 4. Or C you can take any, but and A also you take any, but B must contain all the elements of A in this way. Okay. So now what they are saying, to find a C minus B. From A if we find C minus B, what will be equal to it? The elements of C that are not in B, that is what? 4. Okay. Similarly for C minus A, that it will include those elements that are in C but not in A. That will be what? 3 and 4. Okay, so what do we get from these two? That C minus B is a subset of C minus A. This we have to prove, and we have done. Okay, in this way you can solve the remaining questions of this exercise in rough notebook and solve these first 5 questions in your fair notebook. Okay, thank you.